Hello guys, welcome back to my channel. Today we're going to be looking at an additional mathematics worksheet that I created. And as you can see, you can pause the video, go ahead and attempt the question, and come back and look at the working. Alright, so we get right into it. The first question is from Polynomials, and it says that if x plus 2 is a factor of f of x equal to x cubed minus 3x squared minus 4x plus a, find the value of a. So the first thing I'm going to do is to let x plus 2 equal to 0, which means that x would be equal to minus 2. Now, this is a root. So the fact that this is a root, when I plug it into this expression, I should end up with 0. So this implies that f of minus 2 should be equal to 0. Because when you divide by a factor, there's no remainder. So I'm going to have 2 times minus 2 cubed minus 3 times minus 2 squared minus 4 times minus 2 plus a is equal to 0. Now we can use a calculator to work out most of this. So you don't have to manually work this out because you're allowed to use a calculator. So we have negative 20 plus a is equal to 0. To get a, we simply carry over the 20. So a is equal to positive 20. And that's the value of a provided that x plus 2 is a factor. For question 2, we have 2a and b. It says that the quadratic equation x squared minus 4x plus 6 equals 0 has roots alpha and beta. Calculate the value of alpha squared plus beta squared. Now, even before you can think about alpha squared plus beta squared, we must think of the two most important things. That alpha plus beta is equal to negative b over a, and alpha beta is equal to c over a. We use these two pieces of information to work out anything at all that we want. So what you're going to have here is negative b, but b is already negative 4. So I'm going to have 4 over a, which is 1, so it's just going to be 4. For my second one, alpha beta is equal to c over a. So I'm going to have 6 over 1, which is just equal to 6. Now, how do I get alpha squared plus beta squared? We simply used, well, we can use the perfect square and transpose it, or you can memorize the identity that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Now, alpha plus beta is 6, so I'm going to have 6 squared minus 2 times 6. And this is going to give me 6 squared is 36 minus 2 times 6 is 12. So this boils down to 24. So sometimes we could have used alpha plus beta all square, transpose the identity, or we can memorize this identity. Alright, let us move on to part B of the same question. We have 2x minus 5 over 3x plus 1 is greater than 0. Now, in this question, the problem I'm having is that we have a denominator here. Now, what is normal the tendency is to multiply both sides by the denominator. But here's a problem. If x were to have a value that would make the denominator negative, when you multiply both sides by the denominator, the sign would change. However, if the denominator remains positive depending on the value of x, the sign would remain. That creates a conflict in solving the question. So to eliminate that concept, all we can do is simply to multiply both sides by the square of the denominator, as the square would actually be positive, because once you square something, it becomes a positive, and therefore it doesn't affect the signs any at all. So I'm going to have 3x plus 1 all squared times 2x minus 5 over 3x plus 1, and this is greater than 0, times 3x plus 1 all squared. Now clearly we know what is going to happen on this side. Alright, 0 times anything, that's 0. Now here, by laws of indices, this would cancel out one of that. So I'm going to have 3x plus 1 times 2x minus 5 is greater than 0. Now at this point, there are several ways that we can go about doing this. We can approach this using a number line, or we can use a quadratic graph, because this now represents a quadratic function. And we know that this would actually have a minimum turning point, because if we look at the coefficient of the x term, that product would be a positive, right? And we know that once a is greater than 0, then of course it's going to have a minimum turning point. So since this is in its factorized form, it's being compared to 0, what I could simply do is to write a statement that says let 3x plus 1 equal to 0 and 2x minus 5 equal to 0. Now the process of this, or the purpose of this, is just to get what the values of x are for the boundaries, because we know that the denominator really and truly could never be 0, because we can't divide by 0. So probably we should say this is not equal to 0, just as a reminder. Now x is not equal to negative 1/3 here, because you don't need to show the minus steps. Or we can say that x equal to 5/2. Now, on a graph, and just to get the idea of the quadratic graph, this probably would go faster than the number line. We would find negative 1/3 and would find 5/2. So let's just do a little thing. Negative 1/3, 5/2, somewhere over there. We're not necessarily interested in where it cuts the x-axis, where it cuts the y-axis. We're not interested in the turning point. All we're interested in is the shape of this graph and where it falls. So technically speaking, we say that the coefficient a is going to be positive, so it's going to have a minimum turning point, all right? That's the only thing I need to know. Now, the function is greater than 0. And a function is greater than 0 when it is above the x-axis, because we're looking at the y values being greater than 0. Bear in mind that when you input x, you get output y. So the output is represented by the y-axis, which is greater than 0. So I'm looking at the function in this region. I'm looking at the function in that region. So simply put, let me just get a little space here. The solution, or the range of values for x, would be down here or up here, which would be x is less than negative 1/3 union x is greater than 5/2. So the quadratic approach does work. You can use a number line, but I particularly like this idea. It goes very quickly. And we now move on to the next question that says, let f of x equal x cubed minus x squared minus 14x plus 24. Use factor theorem to show that x plus 4 is a factor of f of x. So at this point, the statements we write become very important. So we're going to start by saying let x plus 4 equal 0. Now if x plus 4 is a factor, x equal negative 4 is a root. Alright, so if x plus 4 is a factor, then f of negative 4 should be equal to 0. So when I plug this into it, I should get 0. Alright, f of negative 4 would be equal to negative 4 cubed minus negative 4 squared minus 14 times negative 4 plus 24. Once again, you can plug all of this into your calculator. If you put all this into your calculator, you're going to end up with 0. So therefore, x plus 4 is a factor. So we have to treat maths as a language, right? We'll move to part B of the question that says determine the other linear factors of f of x. Now, once we have a factor, we can of course find the other factors by dividing this, which we call a dividend, by the factor that we have, which is x plus 4. So it's x plus 4 into x cubed minus x squared minus 14x plus 24. And we say x into x cubed is x squared times my divisor would give me x cubed plus 4x squared. And then we subtract. Now we know that x cubed would cancel with x cubed. So you have negative x squared minus 4x squared, which is negative 5x squared, and we carry down the minus 14x. Now x into minus 5x squared would give me a minus 5x. Minus 5x times my divisor is minus 5x squared, and minus 5x times 4 is minus 20x. And we subtract. Now we have negative 14 minus 20. Now these two consecutive minus signs would give me a positive. So it's negative 14 plus 20, which really would give me a positive 6x, and we carry down the 24. Now x into 6x would give me a positive 6, and 6 times x plus 4 would be 6x plus 24. Now I have an idea that my answer is correct because my remainder is 0, and factors don't leave remainder. Now it says determine the other linear factors. So we're not going to factorize completely, right? Normally when it's factorized completely, we have all three linear factors. We're simply interested in the other factors. So I'm going to be taking the x squared minus 5x plus 6. And since the coefficient of the x squared term is 1, we can use a shortcut. So we want two numbers. When we multiply them, we get 6. When we add them, we get negative 5. So the numbers would be negative 3 and negative 2. So my factors are going to be x minus 3 and x minus 2. And since it says determine the other two linear factors, not to factorize, you could state that therefore the other two linear factors are x minus 3 and x minus 2. Alright? Now if I had asked you to factorize completely, it would have been a different statement, which you'd have had to write the three factors as a product. So the language is important. We now move on to the next question, which says given f of x is equal to negative 2x squared minus 12x minus 9, part 1, express f of x in the form k plus a into x plus h all squared, where a, h, and k are integers. Alright, very important. Now this is just me completing the square. And of course we have a shortcut way of completing the square, which of course you're less likely to make errors with. We simply use the fact that h is equal to b over 2a. So h would be equal to b. Now my b value is negative 12 over 2a. So that's 2 times negative 2. So h would be negative 12 over negative 4, which is 3. K is equal to c minus ah squared. So k would be equal to c, which is negative 9 minus a, and since a is negative 2, you're going to end up with a positive 2 times 8 squared, which is 3 squared. So k would be equal to negative 9 plus 3 squared is 9, 2 nines is 18, so k is equal to 9. So to express it in the form, I'm going to have f of x is equal to k, which is 9, plus a, and since a is negative 2, you're going to have minus 2 into x plus h, so that's x plus 3 all squared. Alright, so that's your 3 marks there. Now in part 2, which is asking you for the maximum value. The maximum value is your k value. So max value is equal to 9. Determine the value of x for which f of x is a maximum. Alright, and then that is when this part is equal to 0. So we're going to have x plus h equal to 0. And h is 3, so x plus 3 equal to 0. X is equal to minus 3. So you can say, therefore, the value of x for which f of x is a maximum is negative 3. Alright, so remember your statements are important, so please input them. Alright, the next question on the sheet says, find a set of values of x for which 3 plus 5x minus 2x squared is less than 0. So what we have here is a quadratic inequality. Now if we're incompatible with the current structure of the question, we can restructure it so we have ax squared first. So I'm going to have negative 2x squares, please watch the signs, plus 5x plus 3 is less than or equal to 0. Alright? And since it's already been compared to 0, we can go right ahead and factorize it. So we're going to go the AC method, which is minus 6. So we need two things. When we multiply them, we get minus 6. but if we add them, we get positive 5. So that's going to be positive 6 and negative 1. So I'm going to have minus 2x squared minus x plus 6x plus 3 is less than or equal to 0. You know the method we pair and factorize. So we can take out a negative x here. We have 2x plus 1. Watch the signs carefully. We take out a 3. We have 2x plus 1 is less than or equal to 0. So minus x plus 3 and 2x plus 1, well, times 2x plus 1 is less than or equal to 0. Now, to find the boundaries, as we say, we can actually compare each of these factors to 0. So they're not actually equal to 0, we're just equating them to 0. So let minus x plus 3 equal 0 and 2x plus 1 equal to 0, which means that if we care about 3, it's going to be a negative 3, and then we divide by negative 1, x would be 3, and x would be equal to negative a half here. So notice now that the coefficient of x squared is negative. So the graph is going to have a maximum turning point. So we have negative a half, we have 3, and we just do our thing. Now it says the function should be less than. So I'm looking at the function below the x-axis. Let me put in the x-axis here. I'm looking at the part of the graph that is below the x-axis. So I'm looking at this section here and this section here. Good. So down here, x is going to be less than or equal to negative a half, and up here, x is going to be greater than or equal to 3. So I'm going to have x is less than or equal to negative a half union x is greater than or equal to 3. Now you might ask, what's the difference between this and the previous graph, which had greater than I think? Normally, the graph itself would have been a broken line because the points would actually not, so the negative a half and the 3 would not be included, all right? Well, that would have taken some time, so we just work with the signs that we're given in the question. But that's how we get the solution for this.